Hello, everybody. My name is John Messenger from GTS Group Australia. Welcome to our webinar today on gSharp with Canary. It's good to have you all here. I'd like to start by introducing Russell Gregg from Canary Labs. Russ will give us a brief introduction of Canary, and then we'll get straight into talking about how gSharp enhances the value of data held within Canary. Russ, over to you.
Okay, thank you. Welcome, everybody. Let me switch this over to my desktop here quickly and validate if everybody can see my screen. And can just get started here. So I'm just going to talk about Canary and the Canary system briefly, and then I'll hand it back to John. The Canary company, we provide the Canary system, and I'm having trouble getting my slides to, there we go. I'm Russ Gregg, and I'm the Director of Manufacturing Solutions at Canary. I work a lot with customers in discussions really about how they can apply Canary to improve their processes, from a business standpoint, not so much technical use of Canary, but how can I leverage the Canary system and partner solutions to really drive value from a process improvement, business improvement standpoint. And the Canary company, we were founded in 1985. This year, we're celebrating our 40th anniversary. So we've been in this business of data collection, real-time trending, and operational visualization and analytics for quite a while now. We are having our 2025 user conference, which is August 11th through 14th next week. So we're really looking forward to that and meeting several of you who may be on the webinar that'll be attending there. And of course, the gHost system will be on display there, and they'll be back in the sponsor booth areas. If after this you're intrigued and you want to attend and chat with those guys and see it operating in a live setting, you'll be able to see that. The Canary system supports really lots of different industries. So as most historians, we're kind of agnostic to your process. So we are used in batch process, continuous, discrete, across multiple industries, and the Department of Defense, and aerospace, and also utilities, facilities and utilities for cities use our system quite a bit. We have sales support around the world. So wherever you are in the globe, we've got partners that can work with you, that we can sell and distribute the software wherever you're at. Right now, we're up over 120 system integration partners that can help you with implementing a Canary system and planning, and then beyond that with your Industry 4.0 digital architecture and initiatives. So wherever you are, we can service you. Just a brief review of the Canary system. The Canary system is based on the Canary Historian, which is at the core, but the system includes data collectors of 7 different types that in our store and forward service, which collects data from the data collectors, buffers it in case there's loss of system, and then forwards it to one or more Canary systems. Once the data is in the Canary Historian, you can query that data or use that data through our View service. And our View service is where all clients interact with the Canary Historian. You can set up what we call virtual views with different hierarchies, asset hierarchies or business line hierarchies, however you want to bring the data and what, however the best mechanism is for drilling into that data. We can make that available, and your administrators can custom config that. You can have more than one view. You can have hundreds of views like some of our customers do that are built for purpose. We have a calcs and events engine for doing streaming event data, taking a couple tags and maybe making a calculation around them or creating data from data. We provide at no charge several different mechanisms for data feeds, and we have our Axiom client tool, which is a real easy to use HTML5 based application that you can run from any modern browser. Just some of our customers that we serve. You can see we cut across those industries, large customers. Some of the interesting customers are the U.S. Navy, who operates a Canary system across its nuclear fleet of vessels. NASA chooses to use us to manage their utilities around their space center, and then of course oil and gas, Coca-Cola, several different electric companies and renewable energy companies. Just an example of a graphical displays that you can build with Axiom. This one is just showing some of the different ways you can look at the data. You can have tables, all sorts of different donut gauges, dials. You can have views into other datas or web links. And then, of course, our trending tool, which is one of the most capable and powerful in the industry. Just an example of a dashboard, this one for engine monitoring. Again, using some of those controls down the bottom, you can see spark charts in a table. So if you just want to get an idea of a trend without the full overhead of our trend link, you can see it there. And then this is an example of a graphical display, just showing flow, more SCADA-like type of displays that you can build to mimic SCADA displays if your operators prefer to see that sort of a graphical display. So again, we welcome you to the webinar today. And if you want more information or interested in talking more about the data historian or applications, you can reach out to us at our website. We have videos out on YouTube. If you go to Canary Labs site, you can get information there. We're also out on LinkedIn and X. So reach out to us if you're interested in learning more about the Canary historian. So that's all I've got. Thank you, and I'll hand it back to John.
Thank you, Ross, for that great introduction to Canary. I'd like to just start myself with a couple of slides, just to introduce what gSharp is. And I promise it's only a couple of slides. And then we'll start having a look at the product and the tool itself, talk about some of the use cases, and also look at how you might be able to leverage this advanced analytics tool with your data and your processes. Okay, so gSharp is a programmable analytics product and package. It is a .NET-based engine for creating complex calculations. So effectively, what you do is you're writing your own coded applications, but these applications are very specific to interacting with your data, consuming that data, performing specific calculations, writing results back into the Canary historian. There are three components to the gSharp product. The server, which is the core component, the scheduling engine that performs all calculations. The gSharp Manager is our administration tool. This is where you can manage all calculations, schedule them, add calculation contexts, do recalculation, and those types of activities. The developer kit really consists of a Visual Studio templates that allow you to build your calculations, test them, debug them, ready for deployment. Currently, gSharp includes these primary features. Obviously, analysis scheduling. It uses what we call natural or event-based triggering. So every time a new event is received for your input tags, that can trigger a calculation. It also supports clock-based scheduling and also uses cron schedules to give you fine control over calculations that need to occur at very specific points in time. The calculations themselves are very contextual, so all calculations are generally written in the context of a view within Canary, and I'll show you what that looks like as we go further into the demo. The management application, the gSharp administrator, is a desktop application, and again, you'll get to see that. There is a function library built into gSharp, so as you interact with your Canary tags, we can provide specific functions to make it easier for you to receive data. So things like summary functions, maximum, minimum, standard deviation, those types of functions. Backfilling and recalculation of your application code. At the moment, that is manual recalculation. And then logging is very, very flexible, allowing you to see what's happening within your calculations. Some of the key benefits that we see is that it allows you to create very complex calculations that take you beyond what the calculation server provides. So this is going to be standard constructs like your looping, being able to interact with external systems, whether that's files, databases, REST services, etc. You can also use third-party libraries. Because all calculations are developed in Visual Studio, obviously libraries that are available as NuGet packages are very much part of the deal. Everything is done within Visual Studio. So as I said, we provide some templates, some project templates, so that you have a framework from which to develop those calculations. You can choose your .NET language, C#, VB.NET, and of course, because it's Visual Studio, you can completely debug and test your calculations before deployment. All calculations are typically configured to use views, so this provides the context. And again, the scheduling engine, we take care of the heavy lifting, so there's no need to write custom service applications to handle your own scheduling, running in the background, etc. Our current roadmap for gSharp, at the moment, we're looking at automatic recalculation, what that might look like, looking to add high availability and redundancy, and also looking into calculation load balancing. These are the things on the immediate roadmap. Looking forward, these are things that we'd like to do, and we don't have a time frame for these as yet. We're looking to upgrade the code base into .NET Core, which will give us a lot more flexibility and, of course, longer support window from Microsoft. Upping the security, so TLS support to client-server communications, implementing performance counters, and we're also looking at implementing a REST API to make programmatic access into gSharp a little easier. If you do need more information about gSharp, or you'd like to have a look at it in more depth, as Russ said, if you're going to be at the user conference next week, come by to the sponsors area. We'll be there. Otherwise, you can contact myself or John Veldhuis in the Americas. Okay, that is enough PowerPoint. Let's go and have a look at some gSharp. Let's go look at the code. So what we're going to do here is I'm not going to walk through writing code step by step, but we will have a look at some existing calculations. We'll touch very lightly on the process of creating and deploying and managing a calculation. So what we'd like to start with is the code side itself. Okay, so as I said, everything is done within Visual Studio. If we're going to look at creating a brand new calculation, we'll fire up Visual Studio. Here you'll be able to see the templates that we have. So I would create a new project. And you'll see that we actually have a gSharp category within templates. If I was to reset this, you'll see that the project types, we have gSharp in there, and these are the available project types. So I want to create a new project for Canary. I'll click on Next. I would give that a meaningful name, and then go ahead and create. And then what you'll find is that there will be a blank template that gives you the basic structure of where your calculation needs to be developed. So there are two projects within each gSharp assembly solution. There is your actual calculation itself, and there's also a testbed project. This is effectively what we use to be able to run the calculation in a context for testing and debugging. When we open it up, this is the blank template. You define your tags. These CL double points, CL string points, etc. These are going to represent our tags within the historian. When I bring in one of the calculations that I've previously written, you'll see how that fits in. Primarily, all code that you're going to write will be in this execute method. This is where the guts of your logic will go. And of course, you can continue to write your own additional methods. If you need to add additional classes to hold those methods, you can do so. What we're going to have a look at is one of the existing calculations that I prepared earlier. And this particular calculation, this uses an external library called mathnet.numerics. And it allows us to run a linear regression analysis over some data and then predict a potential outcome. So to give you some context for this particular calculation, in my Canary system, I have some tags that represent data for wet wells at a sewer pump station in a wastewater facility. And if we were to have a quick look at what that looks like. So this is my wastewater system. Each one of these views, SPS 1 through 5, is a sewer pump station. And each of those sewer pump stations has my data. So for example, I'm currently receiving well level data from the sensor. And this is indicating as a percentage how full the wells currently are. And what we want to be able to do in this instance is potentially predict the time to overflow, the time that the wells will overflow if we don't initiate pumping at a given point in time. And so what we have for this particular calculation, you'll see that I have a point representing the well level. There were also some additional points in my wells, the level sample period. This is the amount of time that I want to receive data for, the minimum number of samples I need to be able to run the calculation, the overflow alarm level, and then finally, my predicted overflow time. This will be the output. So within this particular code, and I won't run through this in great detail, effectively what we've done is we're requesting data from Canary. This well level data get tag data method allows me to retrieve data from Canary for the period that I want. And then if I have less than the minimum number of samples that I need to do my regression, then we're going to log that and exit the calculation. Otherwise, we'll go ahead and pass the data through to the mathnet.numerics function library, and it will calculate, it will run the linear regression analysis, return back to me two parameters, the slope and the y-intercept. We then use that data to then predict the time to overflow. Now, what we'll do is I'll run through and debug this one just so that you can see what this would look like. And then we'll see how this is actually working in real life. In this testbed application, this is where we set up a context to be able to debug our calculation. We need to be able to read real data, but it's important to note that when we're debugging in Visual Studio, results are not written back to the Canary historian, because that may not be a desirable thing, especially during the early stages of your calculation development. And what you'll see here is that each of our tags, the inputs plus the output, we're simply mapping those to the tag name within the view. And then finally, we have a context, which in this case is sewer pump station 4. So we'll go ahead and set a breakpoint here in our code. And debugging, we'll go ahead and start the debugger. Now this will take just a moment to set up in the background. Okay. This little command window, this will be all logged output. So anything that we've logged will be able to appear here in this window. You can see that we're starting that schedule. We've now hit our breakpoint. And so as we step through that code, we have our start time and our end time. Yes, it is the 7th here. I'm in Australia, so day before you guys. We then want to pull in our values. So I have now my samples, and you see that in the period that I'm looking at, I have 60 timestamped values in that data set. And so what we'll do is go and step into that particular piece of code. This is where we're actually just doing a little bit of preparation of that data. We need to have two sets of values, the timestamps and the actual data values themselves. So we'll step through those. This simple regression is the function from the mathnet.numerics library. So we'll go ahead and execute that. And you'll see that we have two values that have come back to us. One is the slope. So item A is the slope, item B is our intercept. So we return those back to our caller. And then at this point, we're going to calculate or predict our overflow time. And again, what we're doing is taking that data, we're going to run it through a calculation. The timestamps have been converted into a numeric format that allows us to then arrive at a predicted overflow time. And here you'll see that I have a result being yesterday. So what that means is that the well is not going to overflow at some point in the future. And then effectively we check, is the predicted overflow time less than or equal to the current time? If it is, we will actually, in this case, output a value of 1st of January 1970, indicating that no overflow is predicted within the future. And that's the end of the calculation. So I can close that window. Now that I've gone and debugged and tested a calculation in gSharp, it's time to actually deploy this calculation. What I'm going to do, I'm going to use assembly versioning, and I will go ahead and increase that version number. I want to release, and then I will simply build my solution. Now that that's completed, what I need to do is go and find the compiled assembly for that calculation, and that was our time to overflow. And what I need here is the time to overflow assembly. I want to grab the debug symbols. And if this was a brand new calculation, I would also need to include the mathnet.numerics assembly, which is a dependency of this application. So I'm going to copy those, and I'm going to deploy that to my gSharp server. If we go and have a look on the server now, this is the gSharp administration application. On the server, we've gone and deployed those calculations to a folder that we call the staging folder. That's an area where all of our assemblies and the dependencies are placed, ready to be imported and managed within gSharp. So as I said, this is the administration application. One of the settings that we've created here is this staging folder. And so to add this assembly, I already have my time to overflow here, and you can see that it's at assembly version 1.02. What we might do is actually, we might remove that assembly just so that I can show you how this is going to be deployed from the beginning. So I would go ahead and click the plus button here, and the assembly registration dialog will go ahead and read the contents of that staging folder, and it will show me all of the available assemblies in there. And you can see my time to overflow is showing as a new assembly because I've just removed the old one. It's no longer registered. If I click on that, we can see inside there the module that we created called wet wells, as well as all of the different tags that we mapped as variables within that code. You can also see the dependency here, the mathnet.numerics library. If I click OK, this process will import and register the assembly with gSharp, allowing me to then create my calculations and my calculation contexts. One of the things that we want to do is these data points that we have as variables within our code, we need to be able to map those to actual points within the historian. You might recall that in the test bed application that we set up that mapping programmatically for the purposes of testing. And so we're going to go ahead and create that so that gSharp knows how to resolve those during runtime. And so I can simply drill into the wastewater view, select one of those sewer pump stations, and then for each data point, I'm going to go ahead and map that tag to the actual tag within the view. And at this point, it actually doesn't matter which asset that I select because all of them are going to have the same tag names. And finally, the well level. I will save that. And now it's time to go ahead and actually create a context. Remembering that a context is going to be one of the actual virtual assets. So we'll go ahead. This is what a context looks like. Again, we'll go ahead and use our selector to select a specific asset. And SPS1 is my selected asset. I'll click OK. If I save that now, you will see that these points have now been fully resolved to the tags within the view for SPS1. It's now time to set up a schedule. So we'll go ahead and add a schedule. You can see the different options that we have available. The clock schedule, we'll have a look at each of these. A cron schedule. Natural schedules are for each of the tags that have been marked as input tags. Now, some of these tags, in fact, the first three tags are all static values. And so I don't really want to use those for scheduling because they'll never get fired. What I could do is use the well level as my trigger tag. If I save that, that schedule has now been saved and registered, and it's now simply a matter of starting the context, and that will now start calculating code. If we have a look in the log file, we'll be able to see that this has been registered. It has we've set it to run. The schedule has started, and now we actually just have to wait for data to come in. If we were to have a look in Canary, we'll see that new data is coming into this fairly quickly. So again, just go back to SPS1, and the values that we're looking for is this expected overflow time. Now, time here, 4:32 a.m. So the potential values that we might receive in this tag, because this is going to calculate every 30 seconds, it will either give me a value of 1/1970, indicating that there is no potential overflow, or it will give me a value indicating that we've predicted an overflow at this point in time. If we were to go have a look in Axiom, and let's make sure that we're looking at the right well. Okay, so you can see that I have a predicted overflow time later today at, in this case, 4:40 p.m. Now, the data that's being generated for our well level is random. It's a simulation, and so take with a grain of salt the numbers that we see here. But based on the current regression that's been calculated for the last period, this is our predicted overflow time. And of course, in a real situation where you have the well level rising, that prediction time may come a lot closer. I will point out that the basis of this particular calculation is actually a real customer. In fact, it's the municipal council in my local area where we built this code for them a few years ago now, because they had a need to have this kind of predictive capability for their sewer pump stations. So that's the basic process of being able to create and deploy a calculation. What we can then do is also, now that we have that one sewer pump station running, what we would like to do is go ahead and add additional contexts. And so again, it's now just a matter of clicking on the plus button under the contexts area, where we can go ahead and again find the next view. This time I might add a clock schedule to this one. And the interval is basically the number of hours, minutes, seconds, or days that you want to run this calculation. We might run this, say, every 5 minutes, which is probably maybe a little more realistic. You can use an offset. The offset allows you to stagger calculations. If you have a large number of contexts and you have a need to stagger those, then you can use the offset. In this particular case, I won't worry about that. Go ahead and save that. Again, you can see that the tags have been resolved. The schedule is there. You go ahead and kick that one off, and that one will now start calculating every 5 minutes, just looking at whatever data has been retrieved for that period. So the way that we manage these calculations should be fairly straightforward. If I need to stop running contexts, again, I can stop a context at any particular point. I can also stop the entire module, or if I want to take the assembly out of service for some reason, I can stop it at the assembly level. If I stop the calculation at a higher level, it will stop all of its children, so any modules and any context running for those modules. And when I restart the assembly, it will remember the status of anything that was stopped below. So it will remember that SPS2 was running. SPS1 wasn't, but also remembers that this particular module is not running. So if I restart that, again, you'll see that SPS2 is now restarted. SPS1 is no longer, is still stopped. Okay. I'm going to go back to Visual Studio for just a couple of moments because I want to talk about some of the other types of use cases that you might find for gSharp. So we'll spend a few more minutes looking at this, and then we'll be able to open up the Q&A to answer any questions that you might have. Some of the use cases that we've identified and explored with our customers involve doing things that you can't do natively within the Historian platform. One of the key areas that a few of our customers have spoken about is that they've done a lot of analytics using Python. For people like myself that came out of school a long time ago, the programming languages that we used, things like Pascal and those types of languages, these days our young engineers are coming out of uni and they know Python. And so I've spoken to a few of my customers that say, well, we've actually done a lot of calculations and analytics in Python. And one of the key challenges that they have with that is that they have to manually extract data from the historian, prepare it, run that data through their Python script, and then look at a way to consume the results. Well, we're using gSharp. One approach that you could use with that is actually to use gSharp and a library called python.net, which would allow us to actually use gSharp to extract our data and prepare it, run it through the Python engine through our script, and then the results of that calculation can then be written immediately back to the historian. So this particular calculation, is also doing a linear regression analysis, but using Python to do so. So again, you'll see that in my points, I have an input point for my well level, and I want to output both the intercept and the slope values from the Python script. As I said, this particular use case uses an open source library called python.net. It's available as a NuGet package, and that's what I've used here in this calculation. This is the actual Python script itself. And there's a couple of things that we have to make sure when we're using Python within gSharp that we've done. We need to have some variables that can be exposed to the python.net bridge. And so here you'll see in my particular script, I've broken this up into two key functions, a main function, and then my linear regression time series function. And when we go through this particular use case, what we're doing is in our calculation, we're bringing in data from Canary. In this case, I'm bringing in aggregated data. I'm getting in averages, hourly averages over the previous 2 days. I'm going to go and convert that into effectively a JSON dictionary, which is how we'll pass the data into Python. We have some code that basically reads the script. I have the Python script as an embedded resource in this calculation. You may find that having it as a separate file in the assembly folder for gSharp would allow you to actually modify the file without having to recompile the entire calculation. The key part that we want for this calculation is this function, run Python code and return. This is where we actually initialize our Python engine. We send data into the Python environment. It will execute the code and return some values to us. So, for example, if we were to very quickly run through this one, let's move that to a debug, and we can go ahead and start that off. You'll be able to see how this one operates. Now, we can't step through the Python code. The python.net bridge doesn't give us that capability. But effectively what we're going to do is, as I said, we'll bring some data in. If we have a look in here, the data set. This is in the format of a JSON dictionary, and so we will go ahead and step into the Python area. We have to initialize the engine. Our return result is going to be a double array. With Python.NET, we have to get this global interpreter lock. Python is single-threaded generally, so we have to have this lock to be able to use Python in our scope. We're going to create a scope in which to operate. We're going to create our data set into what's called a Python dictionary. And this scope.set data is actually one of my variables. You'll see I have a variable here called data, where I'm calling the main function. This is how I pass data from .NET into Python. And so as we do that, we're now going to execute that. So Python is now off doing its thing, taking that code, turning it into a Python dictionary and running it through its linear regression analysis. Depending on how much data there is to work with, we may have to wait a moment for Python to finish its thing. It is taking a while. There we go, it's finished. So now what I want to use is these scope.get methods that actually allows me to read values back from Python. In this case, I'm looking for this intercept and slope variables. They've now been populated by this return from the linear regression function, and I can read the value of those variables back into .NET. So you'll see that I have a slope value and I have an intercept value. We're now going to add those to the array that needs to be returned. We shut down the Python engine, return to the caller, and I now have those results. And these values can be written directly back to the corresponding tags in my sewer pump station wet well. As I said, during debugging, no values actually get written back to Canary. So this calculation has actually already been deployed. I won't go through the deployment process again, but this is one use case that, as I said, a few of our customers have shown an interest in and are starting to utilize gSharp for. As I said, the key benefit here is that you can take your existing investment in your Python scripts and be able to now make those scheduled and effectively streaming analytics. These calculations could be triggered by the input tags again. So you'll see here that I have this Python regression. Again, I have this running in the context of all 5 of my sewer pump stations. With some of these, typically what I've done is scheduled these at a 5-minute interval, so that I now have scheduled streaming analytics using Python directly integrated with my Canary historian. The last use case that I'd like to talk about for a minute or two before we open up for questions is using machine learning with other libraries and other frameworks. And I have a sample calculation using Microsoft's own ML.NET machine learning framework. For those of you that aren't familiar with that, this is a library that Microsoft have open sourced, and it's a fairly comprehensive machine learning framework. You can use it freely. As I said, it is open source. It comes as a NuGet package, so I've implemented that here in this particular code. Now, a quick disclaimer: I'm not a data scientist, and so I don't have an in-depth knowledge of the functionalities that are there. But having had a chat with some of my data science grads, it's a fairly comprehensive library. Now, again, I won't step through all of this code, but the sample that I've done here is doing some anomaly detection. What we're looking for is in this case spikes in our data that would be represented as anomalies. To show you what that might look like, we will go ahead and open up another display in Axiom, so you can see the kind of raw data that we're going to work with here. There we go. So this is a data set showing all 5 of the sewer pump stations. And what we've done is we've built this simulation to simulate random spikes within the data. And what we want to do is be able to run a calculation that will detect and alert us to those kind of anomalous spikes in our data. Obviously, this is just one use case for machine learning in our process data. And for us, it seemed like a fairly obvious one. And so if I look at sewer pump station 3 and 4, you'll see that over the last couple of days that I have a couple of spikes here. If we were to go ahead and change that to maybe over the last day, okay. Again, there's a couple of spikes there. So what we're going to do is run our code to see if we can actually detect these particular spikes. And I'm just actually going to let this thing debug. At the moment, I'm not actually writing out any, actually I am, sorry, I've got a count of spikes that are being written back to the Canary historian. But I'm just going to run this one in debug without a breakpoint, just so that you can see the kind of outputs that we might get and how you might use those within your own areas of use. Okay. So what we've seen here is that for the period of time that we're doing the analysis for, which is the last 24 hours, you can see that we've detected the algorithm has detected what it believes are spikes in the data. The alert column over here, basically it's going to be a 1 or a 0 that will tell us that the algorithm has detected what it believes to be a spike. We've also set out so that we can see the timestamp values that it believes are spikes. And finally, our p-value. We've set the tolerance for this particular calculation at 95%. And so within that 95% certainty, the algorithm has determined that these may be possibly spikes. Of the data set that we're looking at here, I have one spike at 1:36 this morning that is likely definitely a spike based on the data set that it's analyzed. We've also, there's also some code here that will go ahead and look at change point within the data set. And at this point, there's no change points that it's detected. That could be an issue in the way that I've implemented the code, or more likely it's just that there are no change points that fall within the tolerance that we've requested. And so while this is somewhat of a rear view mirror of doing spike detection, using gSharp, you could actually implement these types of machine learning algorithms and use that for real-time detection of anomalies. I could run this, and when I have a high confidence anomaly, send a value back into Canary that then might trigger something else to alert you. Or because it's .NET, you could do something here in the gSharp code that perhaps sends you an email and says this anomaly has been detected in this particular data stream. Honestly, the options and the possibilities are endless, and we use this as an example that you can use advanced machine learning analytics using tools like ML.NET or other third-party libraries, all on-prem. You don't have to send your workloads into the cloud and configure cloud analytic calculations. And for a lot of our customers, keeping this stuff on-prem and having the ability to keep it on-prem and yet get these kinds of capabilities is a fairly important consideration. So that's enough of code. We have about 10 minutes left of the webinar. So what I'd like to do now is open up to any questions that you might have. I think our Q&A is enabled. Let's have a look. There are some questions here. Okay, so I have a question. What's the minimum Canary system version that gSharp requires? We've written and tested this against Canary 25, the latest version. That's the version I have. I don't have an answer to that. It would actually depend on any changes in the API that have occurred, but I believe that we could probably go back to version 23, but we haven't tested that far back as yet. I also have a question. Does gSharp offer prepackaged calculations off the shelf? At this point in time, it does not. We have been looking at potentially doing that, especially something that uses Python, prepackaging the code so that all you have to do is effectively put in your own Python script. But that's something that may not come as an out-of-the-box component for gSharp. For system integrators, and we have some partners that are resellers and integrators of gSharp, they may be able to provide some prepackaged calculations. But as I said, at this point, that's something that we're just still thinking about. Okay. I also have a question here. Is the gSharp server hosted on its own dedicated server? It doesn't have to be. My gSharp server is sharing compute space with other applications. I guess it would depend on how many types of calculations you're running. I have a customer in Canada who is in the process of deploying around 18,000 context calculations. They're running their gSharp server on a dedicated host, but it certainly doesn't have to be. The other question there is gSharp utilizing the Canary web APIs for data exchange with Canary? At the moment, yes, it is. We are exploring and looking at the .NET SDK, but right now we do use the web APIs. In addition to the standard set of read and write APIs, are there any plans to have more in-depth integrations with Canary? We haven't looked at that as yet. I'm not sure what those in-depth integrations might look like, other than being able to read data and write data back. But certainly we're open to suggestions. If you have requests for features or additional functionality, we're always open to receiving those and then looking at how they fit into our roadmap. In terms of running calculations on schedule, can the triggering of the code also be event-based? Yes, it could be. If by event-based, we're talking events coming into Canary, into a tag, we've already looked at that. That's what we call natural triggering. Is the gSharp server compatible with all the standard .NET libraries? We haven't tested all the standard .NET libraries. gSharp is currently written in .NET 4.8. So anything that's compatible with .NET 4.8 or .NET Standard 2, you will have compatibility. For example, the ML.NET library that we've used is compiled against .NET Standard 2.0. So anything that meets those compatibilities, you should be able to use with gSharp. How are the .NET package upgrades handled on the gSharp server? If we're talking about upgrades of our calculations, that's simply just a matter of In fact, we'll have a quick look at that. Probably the thing to do is take our time to overflow and just go ahead and increment that once more. And we'll go ahead and save and build that. Once that's been built, we'll go ahead and grab that again. That was the time to overflow. So whenever I deploy a new version of my existing calculation, those assemblies still go into the staging folder on the gSharp server. And in gSharp, what we'll do is we'll go through the process of adding a new assembly. And once it's read the contents of that, you'll see that that time to overflow is now shown as an upgrade. And that's based on the assembly version. So we currently have version 1.03. So if I go ahead and select that, that will go ahead and register the new assembly. In the background, gSharp will stop and start things that it needs to. But effectively what I now have is an upgraded version of that particular calculation package. I hope that answers the question that we were looking at there. The last question on that range is, can you please provide any details on how security and security patches are handled? gSharp has its own inbuilt security. In terms of being able to manage gSharp, under the settings, we have access permissions. So you can define, there are 4 roles that are defined, and you can assign individual users or groups those roles. In terms of security with Canary, effectively, because we're using an API token, our recommendation would be in that particular space. If we go back over to the Canary historian, we would handle that through generating a specific API token for your gSharp calculation server to use. So if we go under identity and security, you'll see in this particular instance that I have a token specifically created. I don't have Active Directory integration on my gSharp on my Canary server at the moment, but otherwise, what I would be able to do is potentially map that to a service account. And gSharp is typically going to run as a service account because it also has to interact with a backend SQL database. And so you would be able to map that service account to a user in Canary and then provide permissions to that particular user account. That's how we would handle security. In terms of security patches, gSharp is fairly resilient to standard Windows updates. We keep our servers updated, so monthly patch Tuesday. gSharp doesn't seem to have a problem with that. Again, I hope that answers those particular questions. I think that is all of our questions and answers that I see at this point. There was the question here, will this work in Canary version 23.2.1? Again, we haven't specifically tested that version. We may be able to have a look at that and come back to you with an answer on that one. If there haven't been significant changes in the web API between 23 and 25, I would expect that to work as advertised. Okay, I think that is all of our questions. We've reached the end of our webinar. So again, I'd just like to thank you all for attending today. This webinar has been recorded and will be available on our YouTube channel soon. Again, if you have any further questions, again, I'll just share those contact details with you. So if you do need to reach out to myself or John in the US, these are our contact details. Again, thank you very much for your time today. If you're going to be at the user conference next week, please stop by and say hello, and we'll be able to give you a live demo. Thank you, everyone, and have a good day.